Problem 5 says choose a positive whole number, increase the number by 15%, then decrease the new value by 15%. Why is the resulting value less than the original number? So if I get to choose the number and I need to increase it by 15%, I'm going to choose an easy number like 100, because I know if I have a percent and a number, and if my number is 100, that's 100%. I know that 15% would be simply 15. And so when I increase it to 115%, I get 115 for my new number. Then decrease the new value, so the new value is 15, so we need another table, percent and number. The number now is 115, that's our starting value for this new question. So that's 100%. And decrease it by 15%. So I want to know what 15% of 115 is. Let's just use cross products. We'll use a proportion 100 over 15 equals 115 over x. Cross product equation would be 100x equals 115 multiplied by 15. 115 multiplied by 10 is let's just do it up here. 10 115s is 1150, and 5 115s would be half of this, since 5 is half of 10. Half of 1,000 is 500, half of 115 is 75, so 575. And that gives me a total of 1725. So 100x equals 1,725. But I don't want to know 100x, I want to know x, so I divide by 100 to get 1x. 1x is x. Divide the other side of the equation by 100, and dividing 1725 by 100 is simple. You just move the decimal 2 places to the left, since 100 is a power of 10. So you get x is 17 and 25 hundredths. But it says we're decreasing this value by 15. So the 85% would be the difference between 115 and 17 and 25 hundredths. Let me show the hundredths up here, so I have like terms. I need to borrow, making this a 10, then a 9, making this a 10. 10 minus 5 is 5, 9 minus 2 is 7. I need to borrow here, 14 minus 7 is 7. And I need to borrow here, 10 minus 1 is 9. So 97.75. So when we increased the number by 15% and then decreased it by 15%, we ended up with a number that's less than the number we started with. And the reason that's true is because our starting number was 100, and 15% of 100 is less than 15% of a larger number, 115. So when we redefine the whole, when we redefine the 100% as this larger number, when we take 15% of that larger number, we get a larger amount for the 15%, and that's why we end up with less than we started with when we do those two operations. Nine markers cost $11.52. How much should 7 markers cost at that rate? So we're comparing markers to dollars. Nine markers cost $11.52. We want to know what 7 markers should cost. So my proportion is 9 over 7 equals 11.52 over x. The cross product equation would be 9 multiplied by x is equal to 7 multiplied by 11.52. I'm going to do that on the side here to find that product. 2 sevens is 14, carry the 1. 5 sevens is 35, plus 1 is 36, carry the 3. 1 7 is 7, plus 3 is 10, carry the 1. 1 7 is 7, plus 1 is 8. And I was multiplying hundredths by wholes, So my answer should be hundredths. Should have 2 decimal places in my product. So 9x is equal to 80 and 64 hundredths. In order to find x, we need to divide by 9 so that I get 1x. 1x is x. So now I need to do 80 and 64 hundredths divided by 9. 80 and 64 hundredths divided by 9. There are 0 9s and 8. There are 7 9s and 80. 7 multiplied by... No, there's more than that. I was thinking of... I know 9 9s is too much, but I went down by 2 instead of 1. There are 8 9s and 80. 8 multiplied by 9 is 72. Subtracting, we get an 8. Bring down the 6. I should have lined up this decimal in my quotient before I started. There are 9 9s and 86 because 9 9s is 81. Subtract, I get a difference of 5. Bring down the 4. There are 6 9s and 54. The remainder of 0, so we're done. So those 7 markers should cost $8.96. And you would expect them to cost less than this amount, but not too much less, because it's not like 7 is half of 9. So what I'm saying is this answer looks like a reasonable price for 7 markers based on the other price. So that makes me feel good about my answer. Here we have 7 apples, cost $5. We're comparing apples to dollars. 7 apples cost $5. How many apples should I... That's a pretty bad typo there. So it looks like a grammar error, but I'm pretty sure I just hit the O one too many times there, because I know the difference between 2 and 2. How many apples should I be able to buy for $8 at this rate? That's x. So let's again do the proportion. 7 over x equals 5 over 8. I don't see any nice scale factors, so I'll use cross product. 7 multiplied by 8 is equal to 5 multiplied by x. 56 equals 5x. We divide both sides by 5. We get x equals 56 fifths, which is 11 and 1/5. So x is 11 and 1/5, or 11.2, $11 and I forgot we're talking about apples, not dollars. So 11.2 apples. But can you buy 11.2 apples? No, you can only buy 11 apples or 12 apples. So you can't buy more. You don't have enough money for 12. So the answer here is 11 apples. I'm really bugged by this typo. Okay. The Gaudreau family drove to Orlando, then back to Naples. They traveled a total of 375 miles and used 15 gallons of gas. Calculate a unit rate to determine the car's average gas mileage in miles per gallon. Miles per gallon is miles divided by gallons. That's what per means. It means divide. So you take your miles, 375, and you divide it by the gallons, 15 gallons. 375 divided by 15 is pretty easy. There are 2 15s and 37. 2 times 15 is 30. Subtract, we get a difference of 7. Bring down the 5. There are exactly 5 15s and 75. Remainder 0, so 25 miles per gallon, or MPG if you're familiar with that abbreviation. That completes page 2. We'll pick up the review with page 3 on the next video.